grade, and I'm kind of a big deal.
And I'm Cole Jansen. I'm replacing Zach because he's not cool.
And I'm Willie.
We're standing in for Monica again today. Chapter 16, Solutions. In this chapter, we will discuss properties of solutions, concentrations of solutions, and colligative properties of solutions. I guess we'll learn what colligative means.
Solution formation. Solutions are homogeneous mixtures that may be solid, liquid, or gas. The compositions of the solvent and the solute determine whether or not the substance will dissolve. Factors that affect how fast a substance dissolves include agitation,
Giggity.
temperature, and the particle size of the solute.
Solute. Saturated solutions. Each solute reaches a maximum amount where the solvent can no longer dissolve it. This is a saturated solution. A saturated solution contains the maximum amount of solute for a given quantity of solvent at a constant temperature and pressure. In a saturated solution, a state of dynamic equilibrium exists between the solution and any undissolved solute, provided that the temperature remains constant.
Solubility. The solubility of a substance is the amount of solute that dissolves in a given quantity of solvent
Solute's getting us every time.
at a specified temperature and pressure to produce a saturated solution.
Good job, Cole. Oh.
A solution that contains less solute than a saturated solution at a given temperature and pressure is an unsaturated solution.
Liquids dissolving in liquids. Two liquids are miscible. If they dissolve, they dissolve in each other. If they dissolve in each other in all proportions. Water and ethanol, which makes moonshine, are miscible with each other.
Ethanol is alcohol, if you didn't know.
Liquids that are insoluble in one another are immiscible. Water and oil are immiscible together because they do not mix. They just don't mix. Hydrogen bonding. Learned about that last chapter.
Yeah.
Up wave.
Do the wave.
Whee.
Factors affecting solubility. Temperature affects the solubility of solid, liquid, and gaseous.
My parts are gaseous.
Solutes in a solvent. Both temperature and pressure affect the solubility of gaseous solutes.
Supersaturated solutions. A supersaturated solution contains more solute that it can theoretically hold at a given temperature. The crystallization of a supersaturated solution can be initiated if a very small crystal, called a seed crystal, of the solute is added. Rock candy is made by crystallization of this process. Miss L's getting mad.
Alright, so saturated solutions. So we got some pictures here.
Yeah, the mouse.
We having pictures now? Okay, we got pictures now. Unsaturated solutions, more solute dissolves. So seeing that one in the very back on the left, they're
Small
dropping
one.
the solute in, and it's dissolving. There's nothing left in the bottom. And then the middle one, saturated solutions, no more solute dissolves because it's already got too much solute in there, so it just sits at the bottom. And then supersaturated solutions, added crystals grow. So the stuff you put in there actually grows crystals now.
Cool beans.
Yeah.
Concentrations of solutions. The concentration of a solution is a measure of the amount of solute that is dissolved into a given quantity of solvent. See there? Those things at the bottom. A solution that contains a relatively small amount of solute is a dilute solution. A concentrated solution contains a large amount of solute.
It's very concentrated.
It's very concentrated. Molarity.
The most important unit of concentration in chemistry is molarity.
Molarity.
You think for concentration you would need focus, but you really need molarity. Molarity is the number of moles of solute dissolved in 1 liter of solution. When the big M is present as a unit, it's read as molar.
No molars. It's just always molar.
Just
no
molar.
plural. Got a little English lesson in here today too.
Not to be confused with your teeth or Colin's girlfriend.
Sorry, Colin. Oh, so you get this picture of a 5 molar solution, and you got the 5 molars in here.
Got some teeth.
Pun!
And then see in figure 8 here, you got 2 moles per liter. You got your 2 moles in a liter.
Oh, Miss L, you just get us. Good. You get us. Oh, another wave.
The wave.
Do the wave. It's important to note that the volume involved in molarity is the total volume of the resulting solution, not just the volume of the solvent alone.
Calculating molarity. Alright, so we got math. It's not good. So, to calculate the molarity of a solution, divide the number of moles of the solute by the volume of the solution in liters. Alright, so there's your equation. So, your big M equals moles of your solute over the liters of your solution. Alright.
Oh, math!
Oh boy.
Knock this out.
So, we're calculating the molarity of 5 liters of solution that has 2 moles of glucose dissolved in it.
So if you remember our equation, volume goes on bottom and moles goes on top. So cap big M equals,
so
we got it? Okay, we got it. Equals 2.0 moles
So our moles
over
all over our, what is that, 5 liters of solution?
yeah, 5 liters of solution. And then you simply divide and you get,
Rounded to correct sig figs, we get,
oh, that's close.
oh, that's a bad M. Alright.
Okay. Everyone got that?
That's the
That's
answer.
one math lesson. We got a couple more. So the answer is 0.40 mole.
Correct sig figs.
Round to the correct sig figs. It's molar.
Molar.
0.40 molar.
Molar.
Molar gets me. Giggity.
So do I hit 1?
Now you hit 9.
9.
9.
Now hit 2. Or hit 1. And now hit 5.
Okay, we got it.
Okay, we're good. We're good.
What
Alright.
is the molarity of a solution that contains 0.90 grams of sodium chloride in exactly 100 milliliters of solution?
Alright.
So how do we start this? I don't know what I'm supposed to be.
Moles over liters.
Okay, moles over liters, like the last one.
But we have no numbers.
But we don't have any numbers,
So we have to find them.
so we have to find them.
Okay.
So it contains 0.90 grams of sodium chloride. So this we're gonna have to convert into moles.
Yeah, we have to convert that into moles.
Yeah, which means we're gonna have to do some. We have to find molar mass of stuff, right?
We have to find the molar mass, right? We have to find the molar mass. So,
So
hint,
we need the sodium.
get your periodic tables out.
So what's the molar mass of sodium chloride?
NaCl equals 58.443 grams over moles.
Let me read this. All right. So, oh, I'm doing get it, we take our 9.0 or 0.90 grams of the stuff, sodium chloride, put it over 1.
Graham.
I have to put G's with this.
Yes, everybody's looking at it.
Alright. And then times. Snapchats in my class. And then the molar mass of the sodium chloride, which is 58.443 grams. And then your grams cancel out, and that ends up equaling 0.0154. You can read that.
Looks like my handwriting.
Close enough.
Close enough.
And so you're going to put your 0.0154 moles on the top of your equation. And then we don't have liters, we have milliliters. So you have to move your decimal place to the left 3 times so that you just get 0.1 liter on the bottom. And so then you do your calculations, and I'm not really sure what the exact number is, but you have to round it to correct sig figs. So rounding it to correct sig figs, you get 0.2 molar of, this is your final answer.
And that,
right?
my friends, is how you do it.
That's math.
Mind blown. Okay, next slide.
Is there a next one?
Okay.
Oh, that's it.
You-
So before we end this, we'd like to send out a shout out to Owie Wawa
Who's
and
wa-
6 Owl.
Who's working hard in chemistry class?
And homework that you can do.
And homework.
And we got
Homework?
We got homework.
Oh, you temptress.
You can do
You can now do number 1 and 2 on the homework packet, I guess. I'm Connor Aid, and I'm signing off again.
And I'm Cole Jansen, signing off for the first time. Yeah, I think we're done here. I think we kicked these problems' butts.